Okay, so here is a video on product and sum equations, and it's something that we're working on in class right now. We have been talking a lot about what's a product and what's a sum, and how can we change between the two? How can we turn a product into a sum, and how can we turn a sum into a product? And we've been mostly using the generic rectangle to do that, but now we're going to get into solving equations with that. So first off, we're going to do an example here, and we're just going to talk real simply about powers for a second. If I told you I had 5 squared, most of us are pretty comfortable with saying that, oh, that means 5 times 5. And 5 times 5 is 25. So if I asked you what 5 squared is, we know 5 times 5 is 25. A few of us are still making the mistake of saying 5 times 2 is 10, and we know we really shouldn't do that. 5 squared, 5 to the second power, means multiply 5 times 5. So if I told you I had x squared, logically, that x to the second power should mean the same thing, x times x. X to the second power means x times x. So if I told you today we're going to be working with quantity squared, a parenthesis was something squared, and let's say inside that parenthesis, you could have anything. Let's say you have x plus 3. Then x plus 3 to the second power means I have x plus 3 times x plus 3. Basically a product. So we are going to be solving equations that have products kind of built into them. And we're going to be using our generic rectangle to kind of undo our products, turn them back into sums. So let's try an equation and see how we kind of do with a few of these. And maybe under this we'll just write example 2. Let's say we had quantity x plus 4 squared. X plus 4 squared. And we want to figure out what does it equal. Well, we know it equals x plus 4 times x plus 4. We know that for a fact. But we want to take that product and we want to convert it into a sum. What would that equal as a sum? How could we change it so that down the road we can solve these equations? So the generic rectangle says we draw a rectangle, and x plus 4 is kind of like a length, so x plus 4, and x plus 4 is also our width, x plus 4. And we've done a lot of these in class, so we're getting kind of speedy at these. And we label the rectangle, break it up into sections. If it's x plus 4 on the bottom, it's also x plus 4 on top. And if it's x plus 4 on the sides, it's also x plus 4 on the other side. And we're basically going around our rectangle and multiplying each corner to get our area. So x times x is x squared. 4 times x is 4x. 4 times 4 is 16. 4 times x is 4x. And we get our sum, our pieces are going to be x squared plus these 4x's plus another set of 4x's plus 16. And really the only thing we see is we could combine all those x's and say, well, okay, that's 8x's. X squared plus 8x plus 16. That kind of a thing. So I'm going to write that up here. X squared plus 8x plus 16. Okay, well, when I'm talking about solving an equation, I haven't really done any solving yet. All I did was change this product into a sum. So now how would this look in an equation? So here is an equation problem. How would this look as an equation? Let's say we got these directions that said solve for x. Solve for x. And this is the problem they gave you. Quantity x plus 4 to the second power equals 6x plus 10. 6x plus 10. So we're solving for x, we're putting a line down the middle, getting ready to solve our equation, and right away I know I'm going to need to deal with this quantity squared, x plus 4 to the second power. Well, we already did all the work for this. We already talked about how x plus 4 times x plus 4 makes a rectangle problem and turns into a sum. So basically what I'm going to do, here's my little thought bubble here for a second, is we already did, that's a terrible thought bubble, but you get the idea. We already did all the work for this. X plus 4 squared is x squared plus 8x plus 16. And now we're saying it equals 6x plus 10. Oh, I should have done this differently. How about 6x plus 10 plus x squared? Sorry, I made a typo there. A little typo on my end. So all of this is equal to 6x plus 10 plus x squared. Now, there was a lot of work that happens in the step going from here to here. That's a lot of work. It's fun. We like doing our rectangle, but it takes a little bit of effort. So we already did all the effort to get down to that step. Now it's really easy to solve though. Now I'm going to start flipping things over and getting combined like terms. So like I might want to get these x squareds together. I might take this x squared, flip it over so it's a negative x squared. Let's move it. And an x squared and a negative x squared thankfully cancel. I'm glad those are gone. So now I have 8x plus 16 equals 6x plus 10. And this really isn't a hard problem for us. I'm going to take the 6x's, move them over, make them a negative 6x's. Negative 6x and 8x, will combine those together. So we're going to 8 minus 6 is 2x. 2x plus 16 equals 10. And then we're going to just move that 16 over to the other side, make it a negative 16. So 2x equals 10 minus 16 is negative 6. And then we're pretty much done. We're going to divide it by 2, make 2 groups here, divide by 2, and x is equal to negative 3. Now all of this work here solving is stuff we've been doing in class for a long time. We're kind of getting these steps down. It's just this one step up top that's different. It's this step of changing a product to a sum that takes a whole lot of work. Look, we did all this work up above to get that. So that's going to be a big step. That's going to be a big new step for us, kind of working on these problems.